Good morning, sir. I, Aarohi Mishra, along with my teammates Vishwash Patel and Pranjal Singh, are going to present a presentation on our project Electronic Voting Machine using Arduino and LCD display. Our presentation covers the following topics: abstract, project image and diagram, design development, source code, components used in the hardware, features and outputs of electronic voting machine, result, and at last our project video. So, starting with the abstract, first we need to know what is an electronic voting machine. An electronic voting machine is a convenient and quick method of electing a representative in a systematic manner. It's a simple technology that's taken the role of traditional ballot sheets for recording votes. Furthermore, the ballot sheet failed in big population, whereas EVMs proved to be successful and dependable. This project is about the real-time voting machine that was created with the AT89C51 microcontroller and an assembly language software program. It is a real-time operating device with fewer faults and is simple to use. After the votes have been cast, the result can be obtained quickly by pressing the result button. Starting with the design development, there are two switches in this project. One to start the EVM and another to halt the voting process. A user is given a set of switches through which they can vote. The ensuing count can be seen on the LCD display after each vote is cast. The AT89C51 microcontroller is used to control the LCD and switches. Four of these switches on this machine enable the option of casting votes for the candidates. These switches are wired to the controller's pin and made active high. These switches are attached to the microcontroller's port 1. The active level of these switches is set to high. The voting mechanism is started and stopped using the remaining two switches. Both of these switches are set to active low. When the start switch is pressed, the voting system is started, and when the stop switch is pressed, the voting system is stopped, and the poll results are displayed on the LCD panel. These two switches should not be controlled by the candidate but rather by the polling officer. The LCD display device is attached to the microcontroller's port 2. The AT89C51 microcontroller is used in this hardware. It is a 4-port 8-bit microcontroller. Each port has an 8-bit width. It has a flash memory of 4K bytes, 128 bytes of RAM, and two 16-bit timer or counters. The software is written in assembly languages. This program is compiled and software generates hex code. A universal ROM burner is used to burn this hex file into the microcontroller. We can store a huge amount of data on this microcontroller because it has some memory space. This microcontroller can also be connected to external RAM to store more data. 6 switches are connected to port 1 with this microcontroller. 6 tactile switches are interfaced in this device and 2 of these switches are active low. The voting machine is started by one switch. The user is requested to vote when this switch is touched. When the stop button is pressed, the names of the candidates as well as their votes total are displayed. The remaining 4 switches will be used to select 4 candidates. After the public selects one of these switches, a thank you message will be presented. We have the choice of selecting one candidate from 4 with this computerized voting system. We also have the option of increasing the number of candidates. We can enhance the number of switches for candidates by interfacing an 8255 IC. It might be connected to a printer so that a tangible copy of the result could be printed very quickly from the machine. It might also be connected to a personal computer with the results being kept on a central server and backed up on other backend servers. Once the result is on the server, it can be communicated to various offices of the election conducting authority over the network. The microcontroller was used to scan the pole 1 to pole 4 switches in order to cast vote for the candidates. To make the pole switches available for voting, the pole control switch must be pressed first. As a result, the control switch must be hit each time a vote is cast in order to allow the next contestant to vote. This prevents pollsters from casting multiple votes. External interrupts were used to monitor the poll control switch. The state of the voting machine was displayed on an LCD, indicating whether it was ready to take the next vote or needed to be initialized by poll control. It will also show the candidate's name when a vote is cast. The vote results were acquired using a hyperterminal in a computer connected to an 8051, and serial interrupts were used to do so. Any keystroke on the keyboard will cause an interrupt, and the results of the vote will be sent to the computer in order, starting with candidate 1 and ending with candidate 4.
LCD and introducing the automatic PPM. Here in Arduino LED, we write the code for interfacing LED and mounting the number of ports and declaring the result and displaying the results in the LCD. In this code, we have used liquid crystal library that displays interface with pin 13, 10, 11, 10, 9, 8 of Arduino. S1, S2, S3 and S4 are A, B, C and D respectively, and S5 is for the result and the corresponding number of R the pins of Arduino which is connected to it. We are initializing all the boards to 0. In the setup function, we are making all push button access input mode so that we can take it as the input. Then we start the LCD to display and it starts displaying electronic information. Here, the set cursor sets the cursor and moves the cursor to print the next electronic LCD. Then we write I for all the push buttons. Then we print A, B, C and D. In the loop method, it is continuously printing A, B, C, and D and setting the cursor to print the number of votes. Initially, all the votes are printed as 0, and then we check if there is a high signal. That means digital signal, digital read function of S1, which is equivalent to 0. Then we increment the votes accordingly and find the result. Here, on taking the input of number of votes among A, B, C, and D, if, for example, A is having the maximum number of votes, then A will be considered LCD, and A is will be displayed on the LCD display. If the number of votes are equal among all of them, then tie or null result will be the outcome, and no input is taken, then no voting is the resultant outcome. Therefore, we are basically comparing the four values and finding out the maximum amount of four of them.
So now we will move on to the component used. I am Pranjal Singh, 21BC5288. So for this project, we have used Arduino Uno, push buttons, and LCD and breadboard connecting wires. So Arduino Uno. Arduino Uno is a microcontroller board based on ATG 80 Mega 328P. We have wrote an Arduino Uno program and we have used it to make the EVM. And as my teammates have explained the function of EVM, when we use the push button uh, by clicking each time, तो जैसे दोबारा करना पड़ेगा. इसे एडिट बोलना ठीक रहेगा कुछ बता कुछ ओपन बोल. Okay, now we will go to the component which we have used for this particular project, which are Arduino Uno, push button, our LCDs, and breadboard. Arduino Uno is a microcontroller board based on 80 Mega 328P. It has a 14 digital input-output pins, of which 6 can be used as PWM outputs, 6 analog inputs, and a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable, which we have done, and we have written the whole EVM code in our system and ran it on Arduino. Then push buttons. A push button switch is one whose contacts are opened and closed by pressing and releasing a push button on the switch in the direction of its axis. The push button we have used, there are 5 push buttons, one each for the party and one for the final result. LCD, liquid crystal library. display, liquid crystal display. Screens are electrical display module that can be used in variety of ways. A 16x2 LCD can display 16 characters per line on each of its two lines. Each character is presented in a 5x7 pixel matrix on this LCD. Command and data are the two registers on this LCD. The LCD command instructions are stored in the command register. A command tells LCD to perform a certain activity such as initializing it, cleaning its screen, setting the cursor location, managing the display, and so on. The data to be displayed on the LCD is stored in the data register. We have used LCD to display what is the score of voting and to display the final result of the voting by declaring either that A has won, B has won, or is it a tie. Breadboard. Breadboard is a white rectangular board with small embedded holes to insert electronic components. It is commonly used in electronics projects. We can also say the breadboard is a prototype that acts as a construction base for electronics. A breadboard is also categorized as a solderless board. It means the component does not require any soldering to fit into the board. Thus, we can say the breadboard can be reused. We can easily fit the components by plugging their end terminal to the board. Hence, a breadboard is also called plug board. Bread, breadboard is our most basic and fundamental component through which we have connected all our components together. And then the features and outputs. First of all allow the voters to vote for their favorite candidate by pressing a button. So when we press the button, the count of the respective candidate goes up by one. Then, after the voting is done, by pushing the fifth button, we can display the tie-up or no result in a draw condition. Display real-time data on LCD screen. While we press the button, it shows the count going up, and after completing the entire voting process, it displays the final result by pressing the result button. Displays no voting when the result button is pressed without voting any candidate. It is a safeguard button which shows that no voting has been done. Result. The following is a step-by-step explanation of how this voting system works. First of all, the poll control switch must be initialized before the microcontroller may accept inputs. The LCD will display the message "Cast your vote" when the input switches are pressed. The poll switches poll 1 through poll 8 can now be used to cast vote. After voting, the LCD will display the message "Voted candidate." The poll control switch must be now pressed once more to allow the next person to vote. Enables the supervisors to exercise control over the votes. Thank you, and that's the end of our presentation.